Hi there. In sections 2.4 and 2.5, we are looking at adding and subtracting fractions and mixed numbers. When we need to add or subtract fractions, we want to look at their denominators. When the denominators are the same, we're just going to add or subtract the numerators and place that sum or difference over the common denominator. So looking at this first picture here on this page, first thing we see are a couple blocks being shaded. For example, we see this one here and this one here. That is 2, and if we count the blocks in total, 1, 2, 3, 4, 5, 6, 7, that is 2 out of the 7 blocks shaded. And then we can see that we also have 1, 2, 3 out of the 7 also shaded. And we want to figure out how many of the 7 altogether are shaded. And you can see it work through right below the picture, but I'm going to walk it through it with you. So what we're going to do is since this is a sum, we're going to take the numerators and add them together. And then we're going to bring over that common denominator. We do not add the denominators together, only the numerators. Well, we know 2 plus 3 is 5, and again, we bring over that denominator. Always see if it simplifies, meaning is there any common factors other than 1? Between a 5 and 7, there is not. So that would be our final answer. Now, in the next example, we are looking at subtract 6 sevens from 2 sevens. So this whole thing shaded here, the purple and the yellow, represents 6 sevens. And we're just taking away 2 of those blocks there. So just like we did the previous problem, we look at just the numerators. And we perform the operation, which is 6 minus 2, and you bring over that denominator. And then we know 6 minus 2 is 4 over 7. Again, we want to make sure it doesn't simplify. Well, 4 and a 7, the only common factors are 1 again, which means 4 sevens is our final answer. So now what I'd like you to do is I want you to pause the video and work through the your turn example A and B. When you're finished, unpause the video and check your answers with mine. Before we look at example B, let's make sure you at least have example A correct. So it's an addition, so we take the numerators and we add them together, 3 plus 7, and then we bring over the 8. 3 plus 7 is 10 over 8. Now we know that 10 and an 8 have a common factor of 2, so I rewrote 10 as a factorization of 2 times 5, and I rewrote 8 as a factorization as 2 times 4. The 2's cancel, we're left with 5 over 4. If you got that correct and you feel confident about it, go on to example B. If you did not get that correct, feel free to pause the video, try to rework it again, see if you can find your mistake. Go ahead. In example B here, we have 11/18 minus 7/18. So we take 11 minus 7, bring over the 18, 4/18, which 4 and 18 have a common factor of 2. So we rewrite each with a product of 2, 2 times 2 and 2 times 9. 2's cancel, we're left with 2 over 9. In objective B here, we're now going to add and subtract fractions with different denominators. You can pause the video, take a minute, read this, but what it's saying is that you have to find a least common denominator, meaning if your fractions have different denominators, you need to find a common denominator. Okay, let's look at the next page. So for example 2, we're going to add. We have 7/12 plus 3/8. Now when we look at these first, we see that they do not have a common denominator. One's a 12, one's an 8. We now need to get those to have the same denominator. So we need to find a number that 12 and 8 both go into evenly. So we have to think of the multiples of the denominators. For 12, we know 12 is a multiple, but 8 does not go into it. The next multiple of 12 would be 12 times 2, which would be 24. And 8 does go into 24. So the least common denominator here would be 24. Now what we have to do is we have to rewrite each of those fractions as an equivalent fraction with a denominator of 24. So this goes back to a couple sections where we're writing equivalent fractions. So you have to start with your 7/12. Now we have to multiply 7/12 by a factor of 1 that'll give us a denominator of 24. So 12 times what is 24? Right, that's going to be a 2. If we have a 2 in the denominator, we have to create a factor of 1, so we need a 2 in the numerator as well. And then we add, because that's the operation, and we put a 3/8 here. Now we have to think, okay, 8 times what is 24? Right, 8 times 3. And if we have a 3 in the denominator, you need a 3 in the numerator. Now we have to continue to simplify this. So we multiply our fractions first. So we do 7 times 2 is 14, and 12 times 2 is 24. And we want to add that to 3 times 3 is 9 over 8 times 3 is 24. Now, since it's adding here, we want to take the numerators and add them together. So we have to take 14 plus the 9, which gives us 23, and we keep the same denominator of 24. Well, 23 is a prime number, and only 1 and 23 go into that, so there isn't any common factors other than 1. So 23 24ths is our final answer. Now let's look at letter B. We have a denominator of a 6 and a 4. Again, we need these to be the same, so we need to find what is a common multiple of these denominators. Well, 4 does not go into 6 evenly, so let's use 6 to go through its multiples. So 6 times 1 is 6, doesn't work. 6 times 2 is 12. Does 4 go into 12? Yes. So our least common denominator here would be 12. So just like we did in the previous one, we have to write equivalent fractions. So we take 5 over 6, and we need to multiply it by a factor of 1. So we ask ourselves, what number can we do 6 times something gives us 12? Right, that would be 6 times 2. But like we said, this fraction here needs to be equal to 1. We have to have the same number in the numerator and denominator, just like we did over here. So if you have a 2 in the denominator, you need 2 in the numerator. But now instead of adding like we did previously, we want to subtract. And then we have 1/4, and we have to multiply that by something. Again, 4 times what gives us 12? 4 times, right, that's going to give us a 3. So we need 3 over 3. And then we can continue to simplify. 5 times 2 is 10. 6 times 2 is 12. And we're subtracting. 1 times 3 is 3. 4 times 3 is 12. And we know 10 minus 3 is 7 over 12. 7's prime. Only factors are 1 and 7. And so that means that this is completely simplified. Okay, now go ahead and pause the video and try out A and B. Okay. For problem A, you should get 13/14 as an answer. We find the LCD to be 14 because when we look at these denominators, we know that 7 goes into 14 evenly, so that tells us that that would be our LCD. So we take 5/7 and we have to multiply it by 2 over 2 because 7 times 2 is 14. And we add it to 3/14 times, I just put 1 over 1 here to keep the process consistent, but you would not have to do this because we already have the denominator we are looking for. 5 times 2 is 10 over 14, plus 3 times 1 is 3 over 14, 10 plus 3 is 13 over 14. Okay, now go ahead and finish letter B. Okay, for letter B, your answer should be 11/18. Here we find our LCD to be 18. Now we find this because when we look at the numbers 9 and 6, we take the smaller one, 6, and we say, does 6 go into 9 evenly? And we say, no, it does not. It goes in once, but then we have a remainder. So then we start with the bigger number then. We know it doesn't go into 9, so find the next multiple of 9. So 9 times 2 is 18. Does 6 go into 18? Yes, 18 is our number. So we set up our equivalent fractions, find those, and then we subtract the numerators. 14 minus 3 is 11 over 18. Okay, the next idea here is to add or subtract whole numbers and mixed numbers and fractions. Note, this note is going to make this problem a lot easier for you. Change all mixed numbers to improper fractions, and we want to do this first. So if you see mixed numbers, change them to improper, just like we did a couple sections ago. So for example, this problem here, first thing we want to do is change these mixed numbers to improper. So we do 2 times 4 is 8, plus 1 is 9. So this is going to be equal to 9 over, right, 2, because we want to keep that same denominator, and add it to 4 times 5 is 20, plus 3 is, well, 23. So we have 23 over 4. Now we have to add these together, but we notice we do not have a common denominator. Well, between the numbers 2 and the 4, take the smaller one. Does 2 go in the 4? Yes, it does. So here our LCD is going to be 4. So we start with our first fraction, and we have to multiply it by a factor of 1, and we have to ask ourselves, 2 times what gives us 4? Right, that would be 2. So it'd have to be 2 over 2. Plus, and this would just be 23 over 4. Since we have the denominator we need, we can leave it as is. 9 times 2 is 18 over 2 times 2 is 4, plus 23 over 4. Now we have a common denominator, so now we can add these together. And again, we only add the numerators. 18 plus 23 gives us 41 over 4. Well, 41 is a prime number. Only factors are 1 and 41. So that's as simplified as we can go. Okay, let's go to the next page. Same kind of problem, but now we are subtracting and we have a whole number here. So we want to think of, okay, 12 minus 3 and 1/4. Well, let's first change our mixed number to an improper. So we know that we have this 12 minus 4 times 3 is 12 plus 1 is 13 over 4. Again, we got that. We did 4 times 3 is 12 plus 1 is 13 and bring that denominator. Now we have this 12. We want to make this 12 a fraction. So what we're going to do is just put a 1 underneath it because 12 is the same as 12 over 1. Now we still have to find the least common denominator because our denominators are different. Well, anytime you have a denominator of 1 and something else, the LCD is always going to be whatever that other value is. So in this case, it'll be 4. So we have to take this 12 over 1 and multiply it by something. So, well, 1 times what is 4? Right, that's just going to be a 4. So 4 over 4. And then we can subtract 13 over 4. So now we have to make our equivalent fraction. So we take 12 times 4, which we know is, right, it's 48. 48 over 4 minus 13 over 4. So now we have subtraction. So we do 48 minus 13, and that leaves us with 35 over 4. Well, the only factors of 4 are 1, 2, and 4, and the only one that goes into 35 is 1, so this would be our final answer. Okay, now what I'd like you to do is try letters A, B, and C. Again, what you want to remember is to change all mixed numbers to fractions first. Okay, go ahead and pause the video and begin. Okay, here are those 3 problems worked out with the solutions. What I recommend doing at this point is pausing the video, checking all your answers, and then before you look at my work, go back to your own work and see if you can find any mistakes if you missed something. If you're having difficulties finding your mistakes, then look at my work. But you should always make sure you can go back and then complete the problems correctly on your own. And then when you're ready, unpause the video and we'll go on to the next page. What we're doing in Objective D is just solving application problems. So we're going to be working with the fractions mixed numbers, but in the application setting. What I would like you to do first is I want you to read through examples 4, 5, and 6 and see what you can do with them, even if you can just set them up. And then when you're finished, unpause the video and I'll talk about each one. And then we'll have you pause the video again so you can look and try them on your own. So go ahead, pause the video and read through them and do what you can. Okay, so let's go ahead and talk about these examples and then I'll let you try to finish them. So in example 4, we have a lot of numbers going on, and you can see that I highlighted all the different numbers. We have to determine which of these numbers we need and which ones we do not need, because sometimes in our application problems, not every number is needed to solve the problem. So this is about 2 hikers planning a 3-day trip. Over the 3-day trip, they're doing a total of 30 miles, and they have to carry 80 pounds. On the first day, they're traveling 7 3/8 miles, and on the second day, 10 1/4 miles. Question A says, how many total miles? So since this question is referencing miles, we can then take away anything that doesn't include miles as far as the numbers go, and we can get rid of them. So like 80 pounds isn't going to be necessary because it's not dealing with miles. Also, a 3-day trip. We don't need to worry about that number 3 because that's not also looking at the miles. And it's saying the total miles in the first 2 days. Well, if the first day they're doing 7 and then some, and the second day they're doing a little over 10, how do we find how much they do together? Right, we need to add those two values together. If it's easier for you, look at these numbers without the fractions to see if you could figure out what you would do then. If they did 7 miles the first day and 10 miles the second day, you'd be, oh, we just add them together. Well, we do the same thing here. And then in B, it says how many miles will be left to travel on the third day. Remember, it's a 3-day trip. This is the first day, this is the second day, and there's something else for the third day, and they have to add up to 30. So we need to take 30 minus in the sum that we get from part A, and we put that here and we subtract. Okay then, moving on to example 5. A flight from New York to LA takes 5.5 hours. After the plane's been in the air for 2 3/4 hours, how much flight remains? Again, if we forget the fraction parts and we say the flight takes 5 hours and the plane's been in the air for 2 hours, how much remains? We know we'd have to take 5 minus 2. So we do that same thing, but we include the fractions. And once we find that difference, that would be our answer here. And lastly, example 6, we want to find the length of the shaft. This shaft is split into 3 pieces, the first piece, the second piece, and the third piece. And all we have to do to find the total length is add those 3 pieces together. So now that I have these set up for you, now what you can do is go back through and complete all the calculations. When you're done with the calculations, you can unpause the video and check your answers with mine. Feel free to look back in your notes if you need to remember how to do something. Okay, go ahead and pause it. Okay, as you check your answers with mine, you will notice that I changed all my answers to mixed numbers rather than leaving them as improper fractions. When we are working on application problems, it makes more sense to change them to a mixed number because we can answer the question better. For example, how many total miles did the hikers plan to travel the first 2 days? We wouldn't ever answer that with 141/8 miles because that's not common terminology of how we'd answer that. But we would say something like 17 5/8 of a mile. On example 4b, after we then take that 17 5/8 and subtract it from 30, we're left at 12 3/8. And then on example 5, we take 5.5 minus 2 3/4, and we're left with 2 3/4, meaning that was halfway through the trip. And the last one, we have to add all these together, and we get 1 5/16 of an inch. If you need to, pause the video, go back, look at your work, see if you can find your mistakes, and then you can look at my work if you need to help you, but make sure you can do all of these problems on your own. Okay, well that concludes this video. Please reach out with any questions.